Buongiorno, dobre rano. I am Pasquale da Ponte from University of Sannio, Italy, and I am the co-founder of this conference. In this edition, the general co-chair of the conference. I have the pleasure and honor to chair this opening ceremony. And we have the great honor and the pleasure to have here Professor Paweł Drodzej. I'm sorry for a Polish pronunciation of the names. Yes, thank you very much. So Paweł is a friend of us, and he's the Vice Rector for Student Affairs of the Lublin University of Technology, Poland. Please.
Okay. Thank you, dear Professor. Ladies and gentlemen, for first sentence, okay, we're waiting, please, there. Sorry for my language, English language. It's difficult language to me because we are all time speak in Russian in a grammar school. It is great honor to me on behalf of my rector, Professor Zbigniew Palter, to opening this conference and the first time in Lublin University of Technology, first time in Poland. It is for us very important because you have 10 conference in Italy. Next conference start today in Lublin University of Technology. I think that discussion will be in this conference change our mind about space transport. Is very important because we have a war near our border where the aerospace is very important in this conflict. You must understand that we must help our friends in Ukraine to find this war. I think the time if you spend in my university, we have 71 years old, you can see where are in technical and science in Lublin and Poland. In concluding, because we have a lot of not time, I think for person who has first time in our city. City is not very interesting historical city. I think in free time you go to old city and see some historical place. You must remember that in this town, 455 years ago, we sing the real union between two countries. It is Lithuania and Poland. It's the first historical union in Europe. You must remember on this time. And I wish you fulfilled conference. Thank you very much, and sorry for my speech.
Thank you for remembering a very important for me topic. For the first time we are abroad from Italy. And this was very, very, very important because we decided to come here in Lublin due to the fact that our Polish colleague comes a lot, attended our conference, and they give one of the many contributions for the past events. Yes. So we are as, may I say, as at our home. Thank you. So next speaker is Professor Hubert Debski, Dean of the Mechanical Engineering Faculty, Lublin University of Technology, Poland. Please.
Thank you. Good morning, ladies and gentlemen. I would like to welcome you to the Faculty of Mechanical Engineering at the Lublin University of Technology. We are very pleased that you have accepted the invitation to our university as part of Metrology for Aerospace conference. Your conference takes place in the largest and oldest faculty of our university, which the last year celebrated its 70th anniversary. So I wish you a nice stay in our new university and in our beautiful city of Lublin. Thank you very much.
Thank you for your words. I saw some people in uniform, so is from Aviation Academy, something like this. I would like to remember that we moved not only the conference, but also a military part of the conference, because in Italy we organize every year a military metrology for aerospace. So you spoke about the war. And I send you a message. Why you don't organize in Poland again a chapter of the AFSIA, that is an international organization for the support, the cooperation among academy, industry, and the military. Poland is missing in this big family, and could be, I don't know, in Lublin, the beginning of this action. We are here also to propose cooperation, of course. So now my friend Jerzy, I'm sorry, the surname for me is impossible. So for me, it's only my friend Jerzy. Is the general co-chair, and it was the how to say, the main engine of the conference. So please, Jerzy, the floor is yours.
Thank you very much. Good morning, everyone. Ladies and gentlemen, welcome in Lublin. The 11th edition of the IEEE MetroAeroSpace conference is organized at the Lublin University of Technology at the Faculty of Mechanical Engineering, which is the oldest and the largest faculty of our university. The MetroAeroSpace conference is being organized for the first time in history outside Italy. The Lublin region has been associated with all types of aviation activities for a very long time. In our region, there are located such various types of aviation activities as the aviation industry, military aviation, including training and of aviation personnel, as well as civil education combined with aviation sports activities. The Lublin region can also boast of outstanding features in the aviation history of Poland, not only professionally connected with the region, but also coming from here, and whose careers developed outside the Lublin region. As engineer Zygmunt Puławski and Żurakowski brothers, engineer Bronisław Żurakowski, and the test pilot Janusz Żurakowski. There is located PZL Świdnik Leonardo Helicopters Company near Lublin. It's approximately 10 kilometers. PZL Świdnik Leonardo Helicopters Company has manufactured and delivered over 7,400 helicopters to customers in over 40 countries worldwide. There are partner aviation universities such as Polish Air Force University in Dęblin and the University College of Applied Science in Chełm, educating military and civilian pilots to serve in aviation. The Military University of Technology and the Institute of Aviation, both in Warsaw, are 1.5 hour drive away from Lublin University of Technology. There is also a university educating pilots and aircraft mechanics at the Rzeszów University of Technology, also about 1.5 hour away by car. The Lublin University of Technology remains in close cooperation with this university. I warmly welcome you and thank you for making the effort of traveling to Lublin. Today, there is no need to travel several hundred kilometers to take part in online scientific events. All you need is an active account, an armchair, and a few clicks. Even conferences are held online from a sitting position without leaving home. I am even more grateful that you wanted to come here to share your knowledge, experience, and the results of your scientific works. It's not often that we have an opportunity to meet such a wide group of scientists from 6 countries at the Lublin University of Technology. We are very pleased to host participants from Algeria, Australia, Bolivia, China, Germany, Greece, Italy, Poland, South Korea, Spain, Switzerland, and the Netherlands, Turkey, Ukraine, and the United Arab Emirates. It is my honor to welcome the authorities of the Lublin University of Technology, represented by the Vice Rector, Professor Paweł Droździel, and the Faculty of Mechanical Engineering in person of the Dean, Professor Hubert Dębski. He is a host of this several days celebration. I am very pleased to welcome Dr. Giuseppe Bianco, Italian Space Agency. I especially warmly welcome all invited keynote speakers and the chairmen of the military session and all the speakers in these sessions. I am very pleased to welcome the heads and organizers, without exception of all special sessions and tutorials, without whom this conference would not be possible. Due to their number, please forgive me for not mentioning all the names and surnames of the chairmen. I am very pleased to welcome all sponsors and event partners of the MetroAeroSpace and all institutional and academical patrons of this conference. I especially would like to warmly welcome the person, the originator and organizer of this conference from the first edition, a special person involved in metrology, Professor Pasquale da Ponte. Dear Professor, dear friends, welcome in Lublin. I am saying you welcome also on behalf of my colleagues with whom we have organized this workshop. I wish you a successful, a fruitful event. I hope that the organization of the workshop will be at least at an acceptable level. We try to do is as good as we could. Ladies and gentlemen, I welcome you in Lublin for the 11th edition of the MetroAeroSpace Conference, the IEEE International Workshop on Metrology for Aerospace. Thank you very much for your attention.
Thank you, Jerzy, and congratulations for the great efforts and great success of the conference. So now let me introduce, I have the great honor to have here the Professor Giuseppe Bianco. He is on behalf of the President of the Italian Space Agency. The Italian Space Agency support this conference from the first edition, and for first time, we have the pleasure to have here a representative in Poland.
Pleasure for me.
It's very important from this point of view. So thank you, Giuseppe, for being here, for your speech. Please, the floor is yours.
I will be very fast. My name is Giuseppe Bianco. I'm head on the Space Research Department of ASI. I'm here on behalf of Professor Teodoro Valente, who is the president of ASI, which could not be here due to previous institutional commitment. I would like to remind that ASI manages a center located in Matera in southern Italy, which hosts one of the very few fundamental stations of the so-called Global Geodetic Observing System. Hosting a core station is defined in the way that it hosts simultaneously all the space geodetic techniques, namely satellite laser ranging and lunar laser ranging, very long baseline interferometry radio telescope, global navigation satellite sensors, and absolute gravimeter. Later, starting in the year 2003, we started a collaboration, a very fruitful collaboration with the University of Padova and the University of Vienna, based on free space quantum telecommunication. And we published some seminal papers describing the results of our experiments, two of which were co-signed by Professor Anton Zeilinger, which was the Nobel Prize winner for the physics in the year 2022. Last but not least, I would like to mention that ASI is involved in a very important project called the Einstein Telescope Infrastructure Consortium, which hopes to install in Sardinia, in an abandoned mine in Sardinia called SOS Enatos, an interferometer gravity dedicated to the observation of gravity waves coming from coalescing massive bodies in the universe. Within this project, we are involved with the realization and monitoring of the whole geodetic control system. I'm finished here. I wish you all a nice and productive meeting, and thank you again.
Thank you for Professor Bianco, and I hope that your presence here could open cooperation with the local researcher in the field of aerospace.
We have a long history of cooperation with the station Borowiec, that was a satellite laser ranging station in Poland, operated by Professor Szilak and cooperators back in the 90s. I've met Professor Szilak a lot of times. We have a long-standing cooperation.
Thank you for this opportunity. Last but not least is Professor Jaroslav Pitka. He will give us a technical program overview of the conference. Look, with my hand on the heart, my Polish friend did a lot of work. And now you may see the result, preparing for us perfect organizing conference in all the aspects, scientific and social. So, please, the floor is yours.
Thank you very much, Professor Da Ponte. Ladies and gentlemen, I'm Jaroslav Pitka from this university, and I would like to highlight some technical and social details of this event. So I'm skipping some slides because we have very little time. 132 submissions and 105 accepted papers. This is the result, and this is the scientific result of this conference, because the main aspect of any conference is to share knowledge, technology, and so on. More than 400 authors from 6 continents and 90 countries. We have 20 oral technical sessions 14 special sessions, 1 poster session, 3 plenary sessions, 3 tutorials, 2 special events, 1 exhibition named Aeroplane, which will be started today at 1 p.m. As you can heard about the chairs of the conference, I would like to highlight Professor Maria Ruggieri and Professor Zbigniew Pater, General Chairs Professor Pascal Da Ponte, Jerzy Józwik, and okay. I'm sorry. Thank you very much. And Professor Robert Rossa. Technical program chairs, publication chairs, special session chairs, and other people who have made a lot of effort to complete this event. Our special thanks to the reviewers and members of the International Program Committee who have helped to bolster, to highlight the scientific importance of the papers and presentations. Now, shortly about the plenary sessions. Keynote speakers, the first would be Professor Felix Janowski from Delft University of Technology. The second keynote speaker will be Professor Mirosław Wendeker from our university. And the third would be Mr. Philip Steinbiel from Dresden University of Technology. The tutorial session will be held by Professor Konrad Jędrzejewski from Warsaw University of Technology. The second tutorial session will be held by Jiří Zahardala from UDX Research from the Czech. And the third tutorial session will be held by 2 researchers from our university, Mr. Paweł Magryta and Mr. Konrad Pietrykowski. As you can heard, there are military sessions which will be held today. With 5 speakers from various universities and institutions. The second part will be held today in the afternoon. Some information about the awards, conference awards. We are going to award the most outstanding paper of this conference, as well as a paper by a young researcher. This award will be given by the rector of this university. And also, we are going to award a woman who will give her best presentation. This will be awarded by the Polish Metrological Union and the Główny Urząd Miar of Poland. Best paper from aerospace and electronic systems awarded by the Państwowa Akademia Nauk Stosowanych in Chełm, and the best paper for metrology and radar systems awarded by Centrum Lotnicze, also in Chełm in Deputyce. we are inviting you to submit your papers as post-conference papers to the MDPI Sensors Journal. There will be a special issue of this journal entitled "Sensors and New Trends in Global Metrology." Some information about the hosting institution, Lublin University of Technology, its campus, the reception, and Rusty building, in which there will be an exhibition called Aeroplane today at 1 p.m. You are invited to a welcome party today at 7 p.m. As well as gala dinner Tuesday, tomorrow at 8 p.m. These are the maps how to reach those places for welcome party and gala dinner. Lunches for all registered attendees and for the students and volunteers will be given from Koperwłoski restaurant. This is 2 minutes from our building. And of course, we warmly welcome you and invite to have an opportunity of a trip around our city of Lublin. Thank you very much.
Thank you, Professor Pitka, for this information. And now our Vice Rector will open officially the conference. Please.
Thank you, Professor De Ponte. I think I must say, conference is opening. Thank you very much.
So we are inviting you to the technical sessions. Technical session part 1 will be held here in this auditorium. The other 2 sessions will be held in auditorium 2 and 3. So please direct to your rooms, and we are starting.
chapter of reports of AFCIA. Please, may you show, hello? May you show by remote the speaker? Okay. Thank you. Giovanni, the floor is yours for a short, very, very short presentation. Thank you.
Thank you, Pasquale. First of all, good afternoon to everybody. I'm Giovanni Saloni Pinocchio. I'm a former military pilot at the Italian Air Force. I apologize, I can't attend today at the Metrology for Aerospace because I got a scooter injury accident 2 weeks ago, and then I'm not still in a good shape. Let me introduce in a few words AFCEA Association. AFCEA is a professional association for those engaging in defense, intelligence, security, and related technology disciplines. Our membership company comprises military, government, industry, and academic organizations and individuals worldwide. The motto of the AFCEA Association is connecting people, ideas, and solutions globally. The goal is to foster the relationships among the military environment, the industry, and the university. I want to thanks to Lublin University of Technology and mainly also engineer Centuori, Alfonso Centuori, that with his company SDM Polska company will be one of the sponsors of the event. I think that we can begin the International Military Panel. The first speaker is Brigadier General Adam Sowa. Please, General Sowa, the floor is yours.
Buongiorno, Signore Presidente, Mr. Chairman, ladies and gentlemen, distinguished guests, also foreigners. Maybe instead of a few words about myself, as I saw some students and military students, I will give some background from my CV just to emphasize the opportunities for you guys. So my first position at the NATO headquarters was Research and Technology Chief Officer. This is currently so-called flag position. That means that Polish flag is assigned to this position. And it means that we have taken from Americans the position, and always Polish officer will occupy this position. Why I mention it? Because this is the only position at the international military staff. These guys are uniformed military that assist chairman of the military committee in his decisions. And chairman military committee is the highest authority in NATO for military issues or defense issues. And at the NATO headquarters, there is Science and Technology Organization that is comprised from a network of NATO scientists. So thousands of scientists are working just to ensure NATO research superiority over any other possible enemy. So this is the place that many scientists related to defense or in uniforms can work in these structures. I would mention a second thing from my career. So from the NATO, I came back to the Polish MOD. I worked as Armaments Policy Director. Then I became Rector of the Military University of Technology. But I spent there only 1 year and went to Europe. There was a very young organization, European Defense Agency. And I was selected by Solana and then approved by ministers to be deputy chief executive of this agency. And this is the second place where defense guys who are interested in doing whatever, they have a lot of panels, a lot of opportunities, there is money there and so on. So you could develop your interest in defense research. I would like to mention another Italian connection because the other deputy was General Carlo Magrassi, excellent Italian general. Why I mention them? Because together we have started, I was at the agency, among others, in charge of space. And I am going to talk today about space. Alexander Weiss, a German president, was very eager to develop space capabilities, and Carlo was supporting us. So we started a number of very significant projects. One of them was MUSIS, Multinational Space Imaging, and by the way, finally Poland did not join this project, but we started better cooperation with Italy. So now for quite some years we use Italian satellites, so imagery from Italian satellites. Now we can even task Italian satellites to do the observations for us and so on and so on. And I would like to mention that nowadays we are much more ambitious. I will switch to what is current business. Currently I work for the Military University of Technology as a space advisor, and I manage the project who is for us a precursor project opening small satellite applications. Okay. Okay, this is my presentation plan. After this short introduction, I want to say that Poland is now becoming one of the emerging space nations. Traditionally, we had quite a lot of experiments, payloads, and different subsystems in space, but they were part of bigger missions from European Space Agency, NASA, bilateral missions. But we are quite good in, let us say, some elements of satellite. Even in some technologies, Polish firm is the best in the world. It is related with infrared sensors. So such sensors go in American mission on Mars and so on. But we are still aspiring to become a nation that can have its own capabilities to be used in space. Currently, as you know, military bought 2 French satellites that are top of the top, so among the best in the world. And they will be used and operated from the Polish territory. The other approach is to go from bottom up. So we start with the smallest satellites, and this is what I will be talking today, to gain our own experience in designing satellites, producing satellites, using them, operating, which is not that easy. So we take advantage from the revolution that is going on. Maybe I believe it may not work, but this is okay. So about small satellites, these are the guys that are revolutionizing space sector by providing cost-effective, flexible, and innovative solutions to conduct space missions. So for me, there are different classifications, but I just subscribe to this classification that these are satellites starting from 1 kilogram to 500 kilograms, so nanosats, microsats, minisats, and CubeSats. To those who are not in this business, these are standardized small modules. This is why they are called CubeSats, because there are cubes 10 by 10 by 10 centimeters, and these are like Lego blocks that you could build bigger structures using smaller structures. They are very much standardized. There are internet shops that you could buy elements or that you need for you, and especially they very much shorten the time that you could develop what you want. For example, if you have your own idea for experiment or for new technology, you could use such blocks, not being so much professional in building satellites, but it's enough even for good engineer students, fourth year, I believe, of polytechnics or so on. So this helps very much to jump into this business. So we are talking about small sats now, satellites from 1 kilogram to 500 kilograms. And I also summarized advantages for you. This is why they are revolutionizing the business, because they are of low cost, so they are cheaper to build, easier to build. You do not need so much infrastructure to be in this business. They are much more rapidly deployed, and so on. You could see on the slide. I will try this. It works. Okay. For me, I would like to concentrate. There are different satellite constellations. The constellations meaning many satellites. So if there are many, there are usually smaller. So there are not huge satellites, but this is for small sats. Everybody of you heard about such constellations, mega constellation like Starlink. So they are thinking about tens of thousands of satellites in the orbit. This is one mega constellation. There are other mega constellations related to observation, navigation, and so on. These are still not in my, let us say, not as my priority. My interest is much more on formations and swarms. So formations are groups of satellites that are operating in close proximity and in coordinated manner to perform the task. So that means that I should be closer. We can use a lot of small satellites that are maybe individually of special purpose. So what I mean, one satellite can do optical imaging, another satellite can do radar imaging, another can take care about communication, and another maybe about computing or storage in the space. So these are very versatile solutions. I should say that it's easier to say than do. So it's not so easy. It's, I must tell you that space business is really hard. So what looks like it's easy job on the ground, everything in space is very challenging. So I congratulate everybody who has some successes and also some nations. I know that there are participants from abroad. So India has very impressive successes in the space. Really small thing in the space is very hard. And you never know because there are so many uncertainties that you, even if you think that you are 100% prepared, everything can go wrong because this is space. And also the environment in space is very tough. So that's because you, okay, it's very aggressive and very tough and everything must be very special to be there in space. So, on one hand, saying that this is the easiest way to, let us say, be in space. On the other side, you should always be very pragmatic and not over-enthusiastic because this is a hard business. And swarms are, we can say, generally, this is a large number of small satellites that normally should possess a lot of autonomy. So without, let us say, many connections with the ground, they could perform the task. Sometimes they should, like information, share some resources or cooperate closely. As you know, there are such swarms of UAVs who are now doing great business in wars. They're always very dangerous because there are very many. This is like with bees. So one bee is maybe not an issue for anybody, but if there are thousands of them, we have a problem. So this trend is currently in space as well. So I put what I put here in the picture. NASA did very quick experimentation because they started, I believe, last year, and then they already have good results. So there were 4 small satellites testing swarm technologies. Time to space. I would like to spend some time to emphasize this because firstly, I am from military. So for the military, it is so important that you have an idea or you have the capability developed, so you want it now, not next year, not in 3 years' time, but as quickly as possible. So again, small sats, the use of small sats are shortening the time to space. So since the moment you define the mission, you decide what you want, so then you can very quickly implement it in, let us say, industrial processes. By the way, there are new challenges because we do have it in our project that if you build in parallel many satellites, you may have the challenge with the infrastructure, with testing and so on, because nobody buys many, let us say, TVAC, that means special infrastructure that is used for testing in temperature and in lack of air. So, and then, anyhow, we are now making the processes quicker and quicker, and also with testing, we are better, even in Poland. Another concept is rideshare. I will show it in practice for those who are not that close in the business. Rideshare concept is that you may put many small satellites on one and send them in one launch. So 50, 60, or you may have a main so-called payload, so big satellite, and in addition, a number of small satellites. So by this, you have more so-called windows for satellite launch. So now we have contract with SpaceX, and each 4 months you have a window. So each 4 months you can launch if you have something. Talking about the time, you should know that you should have an agreement even 1 year ahead of time. So 1 year before you want to launch, you should have an agreement with Exolaunch or somebody. And then, so this adds to your time. So you have the design, production, then you wait for your launch. And fortunately, other things are also speeding up. 3D printing technologies are very much helping. And space tags, these mean special satellites that are used for transportation. I will have a demonstration for you. So we are in space. And now let's have a look. These are all satellites. You see that they were dispatched or separated. Let's have a look at this, because this is what we are strategically investing also. This is transportation, so-called space tags. So special satellite that transports you to the orbit you want. In some cases, you want to be in a very, very specific orbit. Also, Musk uses this, and now this is why they are quite expensive. We wanted to use them in our mission, but Musk did a bad job for us because he contracted so many thousands of such launches that I would like to make it again. So again, because I would like to show some other things. So now you again see different satellites being launched, as a matter of fact, now in space. And this is this space tag. So this is transport satellite that is very independent. So you see sonar panels. There is a very good propulsion system. And it has inside many smaller satellites and transports them to the required orbit. And now you see there is a small satellite being launched from this space tag. And what I wanted to say also, because this was our idea in the project, this is for our younger colleagues. This you will be building. This is mothership. So this is a spacecraft that is going to act as a mother in a case there are children or smaller satellites inside it for special mission. It is no longer science fiction. So I come again to the simplest solution, because this is quite advanced, but this is space tag, deorbit ion that we wanted to use as a mothership as well. So maybe in the future we will also produce such satellites, because let's have a look how nice this satellite is. So it has, as I mentioned, the propulsion and navigation system to navigate you to exactly the point that you want. But inside you have the standardized boxes that, for example, for CubeSats that I mentioned, you could load them like ammunition. So first, second, third, and so on, and maybe 8 small satellites, and these 2 were to be ours, so third. And then why I call this mothership? Because for the military, a very nice concept is that you do not launch the satellites immediately into space, but the mother keeps them, so protects them. There may be better protection. They do not use fuel. No, they are asleep. asleep in a proper place, and when you want, you activate the mother, and the mother does something with children. And then depending on what the child is, because you could have, again, so you could arrange very flexible missions, having even a few mothers. So you could launch satellite for optical observation, radar, or communication, or computing, or whatever. So you could make a composition of different satellites, just fine-tuned for a special task. So this is, I believe, the direction we are discussing with the industry, encouraging them to invest for the future. And now I would like to tell you a few words about a concrete example of the Polish project. I'm very sorry, I must stay at very high level, so I cannot share the details. So this is the constellation of 3 satellites. PIAST is very good abbreviation from Polish Imaging Satellites, but it's the family of Polish rulers, kings that, let us say, moved Poland to the west, introduced Christianity, and there was the first king and so on. So this was the beginning of Polish statehood, and then Poland became very strong. There was the time that we were the strongest in Europe. One cannot believe, but there were such times. So maybe everybody has something like that in his history. So these, as you see, there is no much text on this. So we will launch a number of small satellites. These are not CubeSats, not nanosats. They are very small microsats, around 25 kilograms, because the concept is we wanted to test a lot of technology that are of dual use and that are for military purposes as well. That means starting from satellite architecture, that you can have a lot of reliability, redundancy, scalability. So from this smaller, you could go to much bigger satellites using modules. So they are also modular. Maybe what I can immediately say, let's have a look, they even didn't have these wings with solar panels, because we need them to be very agile. So to rotate quickly, to change the position quickly, and so on, so to have low inertia. So they are very specially designed in this way. So they are like boxes. So, but we also develop a complete mission control system. I may assure you that this is also a very complicated thing. So you need guys who know how to plan mission, then how to operate the mission, then how to operate any payload. So it's very, very difficult. How much time do I still have? Okay, I should be closing. Okay, so it's good because it's not here. So we have also computer center. We use artificial intelligence to digitally mix smaller quality pictures to make them higher quality. Okay. So we, in orbit, will demonstrate forming. This means that satellites that are far away from each other, that they make formation, then you keep formation to perform the task. They cooperate in performing this task. Okay, they will cooperate to gather imaging. I would like to say a few words about experimentation. It will be very quick. Okay, this is more interesting. So we will perform a number of laser experiments. So we have lasers that detect the satellite and follow it with very high precision. If you speak about lasers, these are millimeters, centimeters. So this is that that level of precision. We will experiment with laser communication, satellite ground segment, also inter-satellite communication. For formations and swarms, we need this inter-satellite communication. So lasers are very, very important in our program. Fortunately, we are one of the best in Poland, and we have a lot of successes with lasers used on the ground. And in case of lasers, the good thing is that this is easier to use lasers in the space than on the ground, because there is no air there. Okay, thank you very much for your attention. Thank you, everybody.
Thank you, General Sowa.
Yes.
Are there any questions from the platea, please?
No questions. Okay. Thank you very much that you do not ask me about my secrets. Thank you.
Thank you, General Sowa. Next speaker is Colonel Karol Budniak. So the floor is open.
Wow, it's so quiet. Good afternoon. So before we start, I have a question. Who has the newest iPhone? Okay, a few guys. Who would like to have the newest iPhone? Okay, so in military aviation, who would like to work on the best aircraft in the world? Yeah, it's few of, okay, I have to make some notes. So thanks for that, and I'm asking about that because I am running the F-35 program in Poland, and the main challenge is to recruit people, actually. So believe me, I expected, when I became the boss, I expected the full rooms of hands. Yes, I am going to work on the best aircraft in the world. The reality is way different, and it's pretty crazy why. So many years ago, let's say 2025, our colleagues, friends, they didn't have so many chances to implement anything new in Polish Air Force. There were still old platforms, MiG-21s, MiG-29ers, Sukhoi 22s, and no chances to attend the big event to implement something new, something modern, something to be proud of. So the miracle happened in 2026, because we had a chance to implement F-16s. So that was the great thing, and everyone who participated in that event was super happy, because first time since 1989 we had a chance actually to do something new. So everyone from other units wanted to join 2 dedicated units who were chosen to implement F-16s. However, there were some issues related with that, and some of them are still valid. So first of all, there are standards, yes? Different things in Poland, different things in US. Different standards in Europe, different standards in US. So first of all, we had different colors on the tubes, on the installations. Then our drawings are placed slightly different than in American styles. So the views are the same, but the location is different. Electric diagrams, they are different. And finally, the units. So imagine the situation. There is a fuel truck coming to your aircraft, and the fuel truck has gauges in liters. Then you have the external fuel tanks with US gallons painted on it. You go to the cockpit, you see the gauge in pounds, and the paperwork you have to do in kilograms. Is it crazy? So it's not super easy to train the guys on something new when you have different standards learned at school when they are in your manual. So there is one common thing with all those issues here. It's language. So starting with F-16s, we somehow forced our Air Force to work in English, which in civil aviation is common. In Polish Air Force, it was not common at all. So suddenly, regardless the standards, units, drawings, diagrams, all the manuals are in English. So now 20 years passed by, and how the situation changed. There is still a huge demand on English, and there is still almost no improvement in people, which means that we are receiving new guys to the military aviation, and somehow they don't speak English. And I don't know, where's the mistake, on which level of education, or maybe people who are going to military, they don't want to speak English, I don't know that. The problem is that it's a huge challenge for us to spend some time not on the aircraft, not on teaching them how to read the US standards, but how to use English manuals. So we started using pretty simple tool, which is the basic handbook, even not for military aviation, but super easy book to simply teach people how to use the US standards in that. Okay, then on our old platforms, we had 4 specialized specialties. So one responsible for airframe and engine, the other for every, let's say, equipment on board, the third group responsible for radio, and the last one for weapon. With F-16, suddenly we had to educate people in way more groups, and there are even not all of them here. In F-35, very soon, we are going to have again just few, because even US discovered that, hey, in very near future, we are going to struggle with manpower. There will be not enough people willing to join military aviation. So we have to make them rather multitasked than look for people who are going to occupy so many specialties like on F-16s. So my task is to implement F-35s in 2 bases. However, it's not easy task because at the very same time, Polish Air Force has to implement many other platforms in many other bases. So I cannot use the same tool like in the past, to simply grab people from different units. That's the first thing. The other thing is also the civil market, yes? People would like to go to the space companies, civil aviation, not, as I asked you at the beginning, the 5th generation aircraft is not always appealing to the young guys. So I discovered that, hey, it's the huge challenge to implement something new, not losing the current capabilities. And I have to combine them. So I have to achieve the goal on F-35, not losing anything on F-16s. So I checked let's say, how the young generation is behaving, because I still feel very young person, but it looks like they are on different planets somehow. First of all, in the past, in our military, people wanted to stay at one location for their whole career. Nowadays, the guys are coming to be uniformed as long as they want to do that, not for their whole career. Then people didn't want to move so often. Now the young people would like to go to the attractive place. So if we are going to implement the newest aircraft in not super attractive place, it's not appealing at all. And then people were attached to what they bought, house, land, or apartments. Now, unfortunately, people are very demanding. So when I am the full class of candidates and I am trying to recruit them to the program, I am telling them how great the aircraft is, and their response is what we are going to receive for that. Very demanding position and very tough for me, and I don't have, pockets full of money, yes, to solve this issue. So I discovered few areas I have to work hard to improve the recruitment process. First of them is demographics. So I learned very quickly that, hey, if we are going to implement newest platform in 2 locations, then we have to check if there are any people who are going to military schools from those areas. And we learned that the people to military schools are gathering rather from the areas close to military schools instead of from around this area and this one. Then language, as I mentioned, English is important, and there will be no military platform in Polish military aviation in other language. So every manual will be in that on any helicopter and any aircraft. So again, military students who are leaving the school, sometimes they have not appropriate level to work on the aircraft in English. Then when we check the unit qualifications, people are still not forced to pass certain exams. So this 1 and 2s, they are according to the NATO standards. We have to pass the exams, and we would like to rather have most of the guys with 3, level 3, level 1 and 2 is often not enough. Then housing. If you are going to implement super new aircraft, yes, even nice looking like this mothership, yes, then you have to give people place to stay. And it's something which even not military is responsible for, but in those 2 locations there are not enough apartments to accommodate few hundred new people to work on those aircraft. Work market, everyone has, or mostly, let's say, have the partner, wife, or husband, and the main question was when my family members are going to work. So let's say in one area there is a local market, the work market 40 kilometers from the city, here it's 70, but not at that very same place when the military guys are going to work. And finally, attractions. So at one base, we could have the biggest city as a main attraction. Here, the sea is attraction, but how many months the sea is attractive in Poland? 2? Around 2 months, yes? So, yes, it depends. So, it's not so appealing as well. But I was told that, yes, that would be a great argument to use, that this is the attractive place because it's close to the sea. There is also something else what changed a lot 20 years ago when we went for the training to US. Everyone was happy to discover America. Everyone. Nobody was able to question that. Nowadays, when we are presenting the locations for training, people don't feel that super attractive. Why is that? Something changed. Too many US movies or too many something else, but people are not appealing even by a chance to go for a training to US. And finally, usually when you want to motivate somebody, you can give him or her a bonus. That bonus often could be related to money, but how much money you can give to the person on this aircraft, whereas you have to implement so many other platforms. That's tough. And in our military reality, the other thing is that people who are going to retire sometimes are even going to earn more than in the uniform. Super challenging task. However, I was trying to determine what my chances are, and as you know, actually in all the systems or the processes, there are some phases. So the first phase is enthusiasm. Everyone is super happy, super excited. Why? Yes, we bought the 5th generation aircraft. After some time, they are disappointed because they see, wow, maybe it's not so sexy, maybe it's not so as good as advertised. So it's a problematic thing. And at a certain time, people started panicking. What's going on? Is it really so hard or not? So we are very often at that level. And there is a huge work to go to this excitement phase again, because otherwise our supervisors are going to look for the guilty, and usually innocent person is punished and person not connected to the program is awarded. So this is something we are going to avoid and always close the loop from panic to enthusiasm. Stay in that level. However, it's super difficult, and if you know the solution, just let me know, because I would like to stay in this enthusiasm area for a long time. Okay, I see that the solution in our reality is simply a huge culture change, because everything depends on people. So as I showed you at the beginning, how to teach people the units, yes, pounds, feet, PSIs, is not everything. The other thing is how to treat people. So teach and treat would be the solution. And then leadership, because this is what we are always looking for, could allow us to achieve the goal, which is to implement the newest platform in Polish Air Forces. Okay, that's all from me. Thank you very much for your attention, and if you have any questions, I am here.
Thank you, Colonel Budniak. Thank you very much for your presentation. I found a lot of similarities with the Italian Air Force students that are attending the new challenge of F-35. Thank you very much. Are there any questions from the platea?
But thanks for that comment, because it's always encouraging seeing that some problems are universal.
Yeah, you're right. You're right, sir. So, next speaker is Colonel Christophe Dragan. The floor is open.
Thank you, Mr. Chairman. Thank you very much. Colonel Budniak just leveraged a bar to a high position with his expression and enthusiasm to present, so I will try to stand it, floor. Also, he has, I would say, the very difficult equation at the end, because it was fully non-linear, so it's really fulfill this equation is a challenge. Okay. I will try to tell you a little bit about problem of the maintenance. So we are moving from the manpower problem to problem connected with data processing, which we will shift a little bit to, I would say, machine power. Today, lecture is connected with approach to damage detection and size estimation, because we deal with metrology related to aircraft structures. I will go through some bullets. I will start with some presentation of the institution I represent, and I will go with some examples of non-destructive testing, health monitoring, and finally of the implementation of those techniques. We are located in Warsaw. The AFIT is a military subordinated research laboratory. which main goal is to solve some difficult technical problems related to military field, but not only. I'm the head of Airworthiness Division. Right now is 50+ personnel, in majority technical engineers and scientists. Our main deal is to support our armed forces, mostly Air Force, with some structural integrity programs, with airworthiness procedures, with the NDT technologies and some R&D activities which we run through some several programs. We collaborate with many great institutions. Also, I valuably would like to highlight our collaboration with Politecnico di Milano. We have together some research programs, also with Military University of Technology and other universities within the European programs. I will start with some issues connected with NDT. NDT is simply something you have to check before you will start to fly. The NDT stands for non-destructive testing. Very often you will hear as non-destructive inspection. And here you will see the whole college of the equipment we use to find something is wrong with the aircraft and figure it out who did this and what perhaps did this and how to solve the problem. Who of you currently did some medical checkups by ultrasonography? Just raise your hand. No one? Oh, yes, I can see. So you already know what you have to, with which you have to deal with. Some nasty thing the doctor had to put on your skin, and the next time he will do it, you will tell him, oh, you decrease the acoustic impedance, and you will see his eyes. Because simply the ultrasonics is one of the techniques, NDT techniques, non-destructive testings, which extend your sight to internal part of the aircraft or your body. So simply, you will look what it is inside with the use of acoustics. In the non-destructive testing, especially in composite materials, which you have a multi-layer, you will observe many echoes or the signals, and based on that, you may infer what you have inside. Sometimes you made mistakes. Ultrasonic inspection in particular is something like you can imagine you take a torch, light torch, and you lightening the structure. But the light is acoustic and it's the same principle that it reflects from the obstacle. The obstacle is the failure mode inside the structure. So it can be delamination, it can be porosity. If you have the signal, then you know, hey, I have something inside. So you can find something based on analyzing of the signal, its position and its amplitude. Right now, due to the powerful signal processing capabilities or embedded electronics, we may deal with really, I would say, exclusive or very fancy way of data presentation. So on the medical checkups, you mostly look at the B scans, or they call it S scans. But in our technical inspections, we deal with many of C scans. It's briefly the view of the structure from the top, or the cross-section as a B scan. And based on that, we may reconstruct the structure deformation geometry. If you will spend a lot of time in the laboratory, you may find different indications. In majority, this you may see here are the impact damages, which means this is a composite which has been impacted. But the machine looks only on the signal. You as a human, something can see something which is different, as my daughter said, hey dad, it's that. Okay, so you can use your imagination looking on the images, but you briefly have to infer what is it inside of the structure. The need for inspection derives from the environmental condition, structural condition, and man operation condition. So many of those conditions really may implement the failure mode inside the structure. It can be impacts, it can be lightning strikes, or many other incidents you may expect as a pilot or maintenance engineers within the aircraft service life. So we use those machines, automated systems, to collect the data, and those data are in majority images. BVID is something you will expect with composite structures. It is something that if you will hit your car, which is purely steel or aluminum, you will see the deflection because of a plastic deformation. With the composites, you will not see it, right? Because the propagation of the energy will go inside the structure and will destroy internal part of the composite. So you will not see it on the top, but the structure will be severely damaged and the transmission of the loads will not be the same. So the criticality of this damage is crucial for further operation of the aircraft. And then you have to make a decision, do you have to repair it or you have to supervise it? There are some colleges of the examples. This is a MiG-29 jet vertical stabilizer. It's a purely composite skin. So we may deal with some damages like this. And then you have to make a decision. Do I have to supervise it? Because sometimes it can fly with such conditions, but sometimes you have to repair that structure. But how to infer about the size? You may look at the Bart-Simpson and measure it, or you may use the automatization. Right now, the computer vision or the machine learning algorithms help you efficiently with that. So here you can see some algorithms which are doing this estimation by themselves. Automatically, we use, for instance, the Hoff transformation or also binarization. You may say, hey, this is fairly simple. Yes, it is, because this is our specimens, certified even by FAA, for very fancy estimation of the size of the damage regarding the technique you use. So based on that, you may qualify and supervise your algorithms for evaluation of the signal. Right now we have terabytes of data, and we are still open for the collaboration for students, for scientists, to analyze them. Okay, here you can see some advancements in the further processing. Those equations are fairly simple than the equation provided by Colonel Budniak, because they are linear. So somehow you may estimate very precisely the size and location of the failure mode. If you have it, then you can measure it and you can compare it along the time. Here you have the example of the impact damage. This is the structure which was hit in the same location couple of times. And then normally the person will have to see it, mark the position, mark the size, make some estimations. Right now, the computer vision algorithms gives you the full automatization, so you can see the algorithms we developed there based on the contour estimation, based on binarization, which fully finds the field of the damage, compare them along the time, and giving you the data for further decision. The metrology. Those techniques are really useful if you, for instance, would you like to implement the new technology. Right now, in the aerospace industry, in the aerospace, we use 7 techniques for non-destructive testing. In majority, they are optical and ultrasonics, but very recently, together with Military University of Technology, we did some research towards terahertz imaging. You probably know this technology from the security, which finds something which is hidden in the luggage. But also the physics is very, I would say, similar to ultrasonics, but operates on the electromagnetic spectra and gives us a chance to find some failure modes in the very thick composite structures. So we used our well-known algorithms, our well-established technology to compare it to efficacy and efficiency of this technique based on the well-known standards, and it gives us a chance to evaluate capability of this technique. Some of the results you may find in the publications. The limitation of the terahertz imaging, unfortunately, to aerospace structures is connected with the electrical conductivity, so it is only limited to glass fibers. Here you have the examples on even the new aircraft that you have to check them correctly, even at the very beginning, to find what are the failure modes implemented during the manufacturing. Or you may have the airliners like this one, which can be obstructed or by the lightning strike or by the maintenance procedure even. So in our inspection cases, because we deal with the inspections like this. This is a 787. We deal with the situations like this a couple of times. If you have a damage, you have to repair it. So within the institute, we elaborate technology to repair the composite structures, and then the algorithms you found before can be used for monitoring of the progress of the damage under the repair, or the repair itself, if it will be some structural problems with this. Here you can see the full-scale fatigue test of the MiG-29 vertical stabilizer. Right now, I would like to move to SHM. The SHM stands for Structural Health Monitoring. It's simply use of non-destructive testing in a permanent way. So it means you can mount on the aircraft some sensors and monitor quality of flying on the one condition, but on the second, I would say the criticality of the other parameters, such as, for instance, harsh landing. So based on the accelerometers you may have embedded on the aircraft and many other sensors, you may collect the data and build the multi-dimensional model of the operational consumption of the service life of the aircraft. Here you can see some of the results of the operational loads monitoring on the UAV, which was used during one of the projects we had. Basically, the SHM, like this, is composed of array of sensors which are distributed on the aircraft. It's like a little bit, if you have a halter testing, you have some sensors on your body which collects the electrical signals and gives you the estimation of how's your heart beating along some period of the time. Here you have acoustic waves which traveling in the structure, and based on the acoustic behavior of the wave with the damage gives you the estimation that something goes wrong with some location, and based on the measurements you may infer where it is located. Here you have, we call this the specimen smart structure, which is a part of composite with embedded sensors inside and on the top, which was impacted. And based on the analysis of the propagation way of the signal, you could infer where this impact has happened and what the size of it, of this impact you currently have to deal with. Today afternoon you will have a lecture a little bit in the more detailed way describing these sensors and the way we collect the data about the crack propagation. Delivered by Dr. Artur Kurnita. He's sitting there, but a more detailed presentation will be highlighted. But it is a very local sensor, but very fairly and simple one, giving you information that the crack propagates in a certain location. In the aerospace community, we deal with the hotspots, so we know where is the stress concentration and where the crack may propagate, so we can monitor them very locally. Also, we can monitor them together with the array of those sensors, which are piezoelectrical transducers, which gives you that something has changed and the crack will propagate. Very first time we use it on the full-scale fatigue test of PZL 140 aircraft. We did this fatigue test in Czech Republic in Prague, but our main headquarters for data collection was in Warsaw, so it was done remotely. Interesting project together with Politecnico di Milano was the SAMAS project within the European Defence Agency. We installed embedded sensors inside the aircraft, inside the UAV, and we were capable to monitor not only the loads conditions, but also we were able to monitor the impacts which may occur during this apparatus flying. There are some tests we did in Italy, in Politecnico di Milano and in other facility. We were, as you can see, having a shooting range, and based on the impacts from the bullets, we were capable to deliver the information, hey, our UAV was hit by the bullet. So this is the information that for the flight condition, it was, for instance, impacted in the very heavy location that gives you the, for instance, information to abort the mission. There is information I will show you at the end, if we will have a time, the video from the full-scale fatigue test of the really big helicopter Mi-24. but also for this full-scale fatigue test, we embedded inside the aircraft the sensors, piezoelectrical transducers, and our sensors. We elaborated in our institute, based on the PhD work, eddy current sensors, which localizes also the crack propagation inside the fuselage of the aircraft. Also, based on our experience, we elaborated, I think, the first HAMS operating systems in our country, which is flying right now on 2 helicopters. This is a fully, as you can see, structural and vibration monitoring system composing of the arrays of the sensors for the structure, for the corrosion, and for the vibration. Here you have the examples that it flies on the helicopter. You have the spectra, you have the signal characteristics. If there's something goes wrong or goes beyond the thresholds, gives you the information that some maintenance work are required or some accidental failures may occur. There are some collages of the spectral analysis. Also, this is a lot of data, which we will try to analyze with the use of machine learning methods. And finally, last but very interesting, that we have tried, and we can localize the anomaly in the vibration remotely, totally non-contact way with the use of laser vibrometry. We did interesting tests in Italy, and right now we are trying to develop those technology based on the technology we developed at the Institute. And finally, also interesting capability, because the corrosion is an issue on the aircraft, and you can quantify and monitor it along the time based on embedded sensors, which fully gives you the information about threats, but not only threats, but about the sources of the corrosion in the center location. Okay, and finally, the very short movie from the full-scale fatigue test of Mi-24 helicopter. I think it is an interesting movie for you, because probably in majority you have not seen the full-scale fatigue test of such a structure, and it was a very, I would say, first full-scale fatigue test in our country of a such big-scale helicopter, together with Bezatals fitting, which is a part of Leonardo company. We completed in 2023. Okay, I think you just stopped because I've heard the announcements that the time just passed by. So thank you very much for the attention. It was a pleasure to present you some of our results.
Thank you, Corrado, again. If there are some questions, I suggest to make questions during the coffee break. We have the last speaker before the coffee break is Lieutenant Colonel Kozlowski with Captain Kozak.
Hello, good afternoon. I'm Lieutenant Colonel Kozłowski. I work at Military University of Dęblin. The subject of my presentation is technical condition monitoring of the military aircraft. Technical condition monitoring can be realized during the 3 stages. During pre-flight testing, realized by technical personnel, maintenance personnel, or by the pilot, during the flight, and during the post-flight testing. Okay. One of this on this slide is presented a path of the signal which is installed on the aircraft. The special proximity sensor of the controlled system. The signal goes from the sensor to the electronic unit as a digital signal. Next, go to via transducer, goes to MISCO computer. The computer generates informations and shows on monitors like MFDs and others, the monitors, the information about monitoring system. Avionics system can also perform tests if necessary on the other subsystems. Example, pressure measurement in the hydraulic system, anti-skid system, environmental control system, and many others. Okay, the first monitoring of the parameters could be provided by maintenance personnel, and we use special service maintenance panel, which is responsible for information about the necessary system used during maintenance on the ground service. Maintenance personnel can read information about parameters shown in the table, like hydraulic power, landing gear, oxygen. Those information are necessary during, for example, towing or parking aircraft. Next, when pilot takes his scene in the cabin, can perform built-in test. One of them is power built-in test. It is a self-test of devices immediately starts after powering them up. The example is the ice detector. After powering the system and communicating with MISCO, the LRU data undergoes and implemented internal tests. After its completion, the LRU sends information to MISCO about the results of the completed tests. Typically, those are tests checking the electronic circuits and logic of given device. The system can compare value of the specific parameters with the boundaries. Another test performed by the pilot is IBIT. It is interruptive built-in test for self-test mode of a given system. The example shows schematically the inclusion of the IBIT test as a part of checking the control planes. The best example of performing the IBIT test will be flight control system. When performing the pre-flight checklist, the pilot is required to perform IBIT. Despite the lack of information about irregularities of the operation of the flight control system, status format in Go, power byte FCS in Go. The pilot must check the flight control system under the working hydraulic system. During iByte, the FCS deflects all control panels to their maximum extreme angles, making the final verification of the functionalities of the FCS. iByte mode provides comprehensive coverage of the critical functions of the FCS, primary and secondary actuators. The status 1 and status 2 formats present information about the efficiency of individual aircraft systems. After turning on power on the aircraft, the avionics system starts a series of tests of internal devices included in the avionics system. Starting with the MISCO computer, MISCO 1, MISCO 2, a number of devices are tested to provide feedback of their performance to MISCO, like an integrator of the data from aircraft subsystems, and until MSG is turned on, it's responsible for data visualization. If one of the devices fails, the PyBit test status in no-go. In some cases, we can perform a forced test of the system again. Example, ice detector has this option. It's also worth remembering that no-go status, the red color, does not always indicate that the device is faulty and the PyBit test has not been passed. We will also receive a no-go message if we are unable to communicate with a given LRU. Below are signals that we can read in the status format. Go, green light, everything is okay. No-go, red legend, equipment in no-go status, something wrong. Non-available, amber color, all buses not available or equipment is not available status. Test, white, equipment in test condition. During the flight, the monitoring system checks all other systems and provides the pilot with feedback on the technical condition. It's worth adding that during the flight, the pilot can view the operating parameters, for example, FCS system in real time. This also to control the trim of the aircraft as well as detect any disturbing asymmetries in the operation of the tail. Disturbingly, this term is imprecise. The pilot technical staff can indicate standards in which a given tail can operate and with differences may occur. Example, during the operation of LEFAS or TEFAS. Flight and balance check. Here we can see balance check. Additionally, the system allows to control the wheel temperature after braking, for example. The COAS, Continuous Automatic Warning System, and VAS, Voice Alerting System, obtain information on the state of the aircraft systems from the MISCO computer, which is an integrator of the data from individual aircraft systems. It's worth adding how many conveniences for the pilot are associated with the such an advanced system architecture. PAP system that is presented on a pilot action procedures. On MFD, the pilot does not have to carry emergency procedures on his knee because the system will tell himself what procedure to follow in the event of a given trade. During the flight is activated system alert generator, which generates information on glad shield, left and right, on the front and rear cockpit, upper part of the cockpit. Alerts are shown as light specific colors on the glad shields. Advisories, color blue, flag derived from the conditions that require aircrew members' attention. Cautions, color yellow or amber, alerts that require immediate attention but don't require immediate corrective actions. Warning, red signal, safety critical alerts that require immediate corrective action. And special alerts, derived from operative conditions for which the aircrew and required to take immediate attention, make specific action or be informed of some events. All data about flight, about technical condition of the system from MISCO goes to crash recorder, to DVDR, the special memory card dedicated for mission, and digital recording unit dedicated for maintenance personnel. This kind of aircraft is flying computer. This is typical avionic system architecture of this aircraft. It's very complicated. And the last stage of the testing is post-flight. We also have here the built-in test called MBITE. This is the third kind of byte. It's called maintenance byte, communication mode with external software test kit in order to intervene in a given system. On the example of the flight line test, FLT, enable to download data from FCC computers access to non-violate memory and performing rigging of the control surface. This DRU, we know what is for, and removable memory card is specially prepared before the flight, put into the DRU. All data about technical condition of systems are recorded on this memory card, and after flight we can check all data via GSS laptop. In this stage we can quickly check if something wrong with aircraft, if some fails occurred, and then all data goes to special LSS logistic system support. If something wrong, we can do additional test. For example, perform tests on selected sensors using dedicated GSE. On this slide, we have EMFP, the special integrated multifunctional probes that gives us, or pilot, air data during the flight. Static pressure, dynamic pressure, angle of attack. If during the flight some fault occurs, we can check using the special external devices. This is the example of special software dedicated to reading FCC data. We can also prepare the new flight control computer before installing on aircraft. We can upload special software and prepare to to work on aircraft. To check selected systems, we must connect it to aircraft external power sources like air conditioning, hydraulic test bench, electrical power units, and then we can perform, for example, backlash, to connect backlash to check flight control system as shown on the picture. So it's very complicated to provide many tests during the maintenance after the flight. Thank you for your attention.
Thank you, Korzinski. I think that we are at the coffee break, and I invite all the people to come back at 20 past 4 for the second part of the international military panel. Thank you very much. See you later. Bye. Pasquale or
Grazie, tra poco. Grazie, arrivederci.
This was unexpected, but all right, we roll with it. At least I'm not going to be the one that wraps up the entire session. So it's going to be a bit easier to maybe keep you engaged and entertained during my presentation. Also, it's a harder task because I'm the only civilian in this panel, so I feel like it's even a harder job for me on this side. Nevertheless, I'll do my best. My name is Carmine Varriale. I am assistant professor of flight mechanics at the University of Delft, so Delft University of Technology. In particular in the section of flight performance and propulsion. Just to give you a bit of context of where I come from, what the activities that I carry out at the university. I also do this, I feel a bit of a pop star. I defended my research, my PhD research a couple of years ago on the topic of flight mechanics and performance of direct lift control. That is the ability to control an aircraft, whatever it is, directly in the vertical axis without pitch moment. And in particular, I was looking at applications for box-wing aircrafts, staggered box-wing aircrafts. It's stuff that looks like this, quite unconventional configurations with two fixed wings attached with side wings. And on this multi-wing system, you can design and allocate a lot of control surfaces that gives you redundancy for control in the longitudinal and vertical axis. So more in general, I've been working on more unconventional aircraft designs, configurations, both for the performance and the design optimization. All of them had, to some extent, redundant or interactive control surfaces. Maybe you've seen the Flying V in the news. It became quite popular a few months ago, a few years ago probably. But also others like the Duke, as we call it over here on the bottom right, with the propulsive empennage concept that has a propeller in front of two elevators and two rudders. So quite strong aeropropulsive interactions. This is where I come from, basically. In order to study these wild animals, if you want, we could never rely on statistics, on previous knowledge. So we always had to go with physics-based analysis that are automatic in nature, because you cannot really design the analysis tool for one. You have to be able to comply with all of the weirdness of this aircraft. And the system that I've been using most often is, the framework is the one of model-based system engineering, so used for simulation-based design optimization. I've been always working in terms of designing frameworks for analysis rather than ad hoc solutions for one specific only. Looking ahead, I would like to take this to the next level. I'd say looking at the future of my career, I would like to move from aircraft design to aircraft and trajectory optimization simultaneously at the same time. And I would like to move from the paradigm of model-based system engineering to the one of knowledge-based system engineering, where we can hear something on the phone. I don't know if it's on the other side, but okay. So the difference between model-based and knowledge-based is now the model is not at the center, but the experience of the engineer is at the center, and it's used to model different aircraft automatically. The overall idea, the goal that drives me, that's going to drive me, is to go from user input, imagine aerodynamic models, propulsive models, mass inertia, whatever, to a flight simulation in 2 clicks, where all the knowledge of the process in between is contained in some analysis framework. As you can see, there was a propeller there because I've slightly transitioned from fixed wing only also to rotary wings in different forms, propellers, rotors, and in the latest work that you're going to be seeing in September, if you come to ICA's conference in Florence, or if you look some literature by the time, I've been looking at rotary wings as well. In particular, in this case, we were looking at optimal approach and departure trajectories for UAVs, with a flavor on the acoustic impact that they have on population. So I was in charge of looking at the trajectories. They are optimal for minimum time or minimum distance when performing an approach or when performing a landing from a vertiport. And my colleague Furkat Yunus from TU Delft was looking at the noise footprint. So in this case, it was on a flat terrain, so very abstract scientific study, but there's a companion paper, I think that's being presented this week at the IEEE SEAS Aeroacoustic Conference in Rome, where he also looks at urban scenarios, with skyscrapers and houses. And it gets quite more realistic. So today, starting from those rotary wings of UAVs, today I'm here to talk about other type of rotary wings, in particular about the operations of unmanned helicopters in maritime scenarios. Why is this relevant? First of all, well, helicopters are capable to take off and land vertically. That comes quite handy when you want to operate on a ship. And unmanned helicopters in particular are cheap, or for sure cheaper than the full version manned ones. So they can also be expendable, without so much risk and so much cost, if the mission doesn't go as planned. Furthermore, they are smaller, so you can store more on deck. You can carry more for the same mission. You can deploy them in swarms if you want. And they are able to deal with extreme weather conditions with more agility, because they're smaller and so more agile. What is the scope of the study that I'm going to present to you is about helicopter trajectories to approach moving ships. So we're not going to look at the details of a landing maneuver, but just approach from far to above the landing deck. And in windy atmosphere. So we're going to look only at macroscopic wind and not turbulent field because of the ship. And I should also say that this is still, as of now, work in progress. It's been carried out hands-on by the person you see on the left, Mr. Dami Silver. He's a master student at the aerospace faculty at TU Delft and also lieutenant commander of 3rd class for the Netherlands Defense Academy. So I'm his main supervisor on the top, of course, and I'm supervising with my 2 colleagues, Professor Mark Voskale from the Netherlands Defense Academy as well, and Professor Marilena Pavel from the section of control and simulation at TU Delft. So how do we proceed? How do we even frame the problem? First of all, you start looking at the operations that are currently ongoing, well established. For manned helicopters, the landing procedures, so really the final approach, if you want, are prescribed. There's NATO regulations everybody has to comply with, and there's a bunch of options people can choose from depending on how they want to design their operations. You can approach from the side, you can approach at a 45-degree angle, or straight onto the deck from behind. Depends on the choices that you want to make, but they are very well prescribed and constrained. So no space to decide anything really there, to optimize anything. But for unmanned helicopters, there's a bit more space. So the literature kind of agrees that a vertical landing above the deck is advised, as you can see here. But the way you reach that hover point above the deck is free to choose. So the job is up to us to provide a way to do that maneuver. And the way that we decided to do it is to use optimal trajectories in a way that I will explain with the following slides. The thing is, there are some limits we have to comply with. They depend both on the operational aspects and the performance aspects of the vehicles involved. And these operational limits are estimated, are measured in a very structured way right now for manned helicopters. They are calculated for a given ship-helicopter pair, so that's already quite specific, and for a given landing procedure, as the one that we saw before, so even more specific if you want. And they are simply measured with extensive field testing. There's no other way. So people really go out at sea, they wait until the weather is bad enough, and they start testing with the pilot in the loop, and all the ship is operating. You can imagine how expensive and costly and risky and complex in general this is. So what they end up with is what we call SHOLs, ship-helicopter operational limits. What we would like to develop now is what is called SUOLs, so ship UAV operational limits, which are still in design, let's say. So how do we visualize those limits? We use a chart like this, where on the radial direction you have increasing wind speeds, and in the angular direction you have different wind directions relative to the ship heading. So for every point in this diagram, you can perform your simulation depending on what the weather is that day. If your wind speed and wind direction is something, you are located in one point in this diagram. You perform your test by going out at sea. If the test is successful, then great. You can place a green mark on that condition, otherwise not. And the region of successful tests has a boundary. That boundary is exactly your ship-helicopter operational limit. So you know that when you want to perform this maneuver, you have to land an helicopter on the ship. If the weather conditions are inside that limit region, you can do it. Otherwise, you should probably relocate or postpone or find another maneuver. The question for us is then, how do we characterize this SUOLs diagram when the approach procedures are not prescribed? Because I want to remind you once again that these are really tailored to a ship helicopter and to a specific maneuver. So there's no degree of freedom there. We just measure what we can do and what not. So how does it work when we don't have to decide it? We're proposing a framework based on optimal trajectories. And in order to do so, we start looking at these two models, one of the helicopter, one of the ship. The helicopter is a rather small orange eye helicopter, unmanned, from the Netherlands Aerospace Center, NLR. So 100 kilos with 3.3 meter radius, rotor radius. And the ship is a Holland-class OPV, so 100 meters, more or less, total length, with a landing deck of 29 meters length. For us, these are going to be 2-point masses, so what matters? So how do we play with them? How do we make them perform as they should? This is just a list of assumptions, but I can support you later with more details if you want. So the helicopter is modeled as a point mass with 3 translational degrees of freedom, up, forward, and lateral, of course. But we include also the possibility to rotate by including the fact that the thrust vector can tilt with respect to the body axis. Of course, we consider the induced velocity of the rotor. It's a uniform inflow according to Glauer theory, so the most simple one, but also the most robust one. We include induced and parasitic drag for the rotor and the fuselage, and ground effect, which of course is relevant only in the final stage. For the trajectory optimization, we decide to rely on the framework of optimal control theory. That's an evolution, modern evolution, if you want, of the calculus of variation, which ensures that the trajectories are globally optimal, so not just at every time in point, at every step in time. And yeah, we decide to minimize, so to calculate the trajectories, then minimize the global time to perform the approach maneuver with the smoothest control. So what we want to avoid is big spikes in thrust and power, so basically prevent bang-bang control, which is very unnatural. And of course, we set up a bunch of constraints to make these trajectories operational to some extent. We constrain max thrust, max power, never exceed speed, altitude, and of course, we want to avoid collisions with the ship. So all of these are translated into equations, of course, but I'm not going to bother you with that. How do we proceed in carrying out the analysis? We have our ship is moving north, and we decide to test different initial positions of the helicopter, which you see aligned over here. So we're going to have 4 different initial positions. One is south of the ship, one is southwest, one is west, one is northwest. And for every of these positions, the aircraft always starts 1 kilometer away from the ship at an altitude of 20 meters. So those are fixed. The ship is moving north, no matter what, at a constant speed of 16 knots. At the same time, the wind is modeled as a power law, so atmospheric boundary layer model. It's a simple one, but it's quite realistic after all. And we decide to also iterate over the intensity and the direction of the wind speed. So we have 4 intensities, including 0 wind speed, and a lot of wind directions all around the compass, if you want. So if you put it all together, this is a lot of combinations, which means a lot of information comes from these experiments, matrix of experiments, and we have to find a nice way to put it all together and synthesize some guidelines about these shoals. So let's start looking at some preliminary results. On our side, we decided to proceed in the following way. First, we start with a baseline scenario, which is the one with no wind. In this case, you can see that this is the top view, so the helicopter starts from southwest, in this case, and tries to approach the ship and finishes here. The ship itself is moving north during the simulation, so everything seems like it's working fine. And of course, it loses altitude from 20 meters, that's the initial altitude, to 5 meters, which is the hover altitude above the deck. And these are also, at the end, they are proceeding with the same speed, so it will stay in hover above the deck. It's not just an instantaneous point. So this is our baseline scenario. Starting from there, we start, for a given wind speed, we start seeing the effect of wind direction, of course. And you can see, actually, I should say that trajectories change quite dramatically, so they are very different. This is also actually achieved not only with wind direction, but with wind speed. You can see that for very high wind speeds, the trajectories start to become quite different from the standard ones, and there are no real clear trends. Both in the top view, but also in the altitude direction, if you want. You can still see some differences. So how do we synthesize this information from such a large amount of data? We decide to create an extended generalized version of the shoals charts, if you want. In this case, we are proceeding with the following one. If we want to plot flying time, meaning that every colored point inside this chart is the flight time that it takes to complete that mission, we can see that we can have 4 different charts corresponding to the 4 different initial positions of the helicopter. So the top left is when the helicopter starts south of the ship. And you will see that then when the wind blows from the tail, so when there's tailwind on the helicopter, you will see that obviously the flight time is slower. When it has headwind, it's higher. I mean, this is not surprising, but it verifies that the visualization and the synthesis is very effective. So it makes you get a lot of information quickly. And the same is true for the other positions in the other charts. Same as flying time, that's the most immediate one. You can also plot the power required for all possible combinations. You can start getting an idea of how intensive that approach and that landing phase is on the engine, on the battery of the airplane, of the helicopter in this case. More interestingly, I think, for military operations, it's what we decided to propose here as a similarity to the baseline. So what we're doing is measuring the difference between a given trajectory in windy conditions with respect to the baseline trajectory with no wind. And that's because we thought it gives us an impression of how much you should deviate. You're going to deviate from a very clear reference condition that you can keep in your mind. You can visualize in your mind, because with no wind, it should be more intuitive to understand what's the optimal trajectory. So to calculate this difference, we're using the longest common subsequence algorithm, which is an algorithm to estimate the difference between two random time series of data. I'm not going to go into the detail of those, but when we plot this LCSS parameter, it's normalized always from 0 to 1. So that also allows us cross-comparison between cases if we want. And we can have a quick measure of how intensive on a general metric the new trajectory, the new flight, the new weather condition is with respect to the baseline. Now what you also see on top on these charts is these dots of various shapes and various colors. These are it's a legend that we use to represent when the constraint of the trajectory optimizations are not verified. So these actually tell us, for example, the red triangles will tell us that in these conditions of wind, speed, and direction, the power required to complete that mission is more than the power available. So that flight condition actually is infeasible. The approach cannot be carried out. In a similar way, in other conditions, we see that the collision is unavoidable, and if it was to be avoided, another constraint would be broken. So in another case, those conditions are not feasible. And with the circles of different colors, we see how intensive it is on the powertrain. We have metrics for the percentage of the maximum power available we have on board that is used. So this, if you want, is a synthetic representation of what's going to become the new shoal limit or SUOL limit boundary. By tracing a line between all these points, you get the infeasible trajectories. So effectively, your operational limits. Let's put it all together, draw some conclusions. We developed actually, still developing if you want, a physics-based simulation methodology to come up with optimal and operational trajectories. We propose, and this is still to be debated, a synthetic representation of the performance in an operational scenario that allows us, in our view, to quickly extract these ship UAV operational limits, just at a glance, if you want. So we claim that this can be supportive for field testing by saving money and logistical complexity beforehand, and also support decision-making when actually in the field. Some ideas for future work from my personal side. It would be nice to start looking at the wake modeling behind the ship, because that's really where the complexity happens. And for my really personal point of view, I like to verify and validate these methods using multi-fidelity models, so high-fidelity modeling, both for the dynamic side, by including the rotational degrees of freedom, and the aeropropulsive side. That wraps it up. Thank you for your attention, and please ask any question. I'll try my best to answer them.
Thank you, Professor Variale. Your presentation was very interesting. I worked in a similar project in 2015 when I was in charge at the Italian National Aviation Authority. Are there any questions for Professor Variale from the platea? Pasquale, you work on the drones operations.
No, there are two questions from platea, and please wait. Okay, thank you.
Okay, so thank you very much, Carmine, for your comprehensive and extremely interesting presentation. I very much appreciated that. You said at a certain point that you didn't want to bother us with the mathematical formulation, but as you may know, since you know me pretty well, I'm actually pretty interested. So my question is, could you explain in very simple terms how the trajectory optimization was actually carried out in mathematical terms, if you can?
Yes, I'll try my best in very simple terms. So it's a global optimization, meaning that you don't optimize only the next step, but you optimize the entire trajectory as a whole, meaning you have to prescribe all the constraints as path constraints that the aircraft has to comply with throughout the entire optimization. And yeah, this is in the framework of optimal control theory. The problem is described as in terms of a bunch of nonlinear constraints, inequality constraints, and equality constraints. And the equations of motion are part of these constraints. These are called the dynamic constraints, basically the rule of the game, yeah? The rule of how the aircraft should behave. This is all capped by a global objective function that the optimizer tries to maximize in this case. Okay, or minimize, it doesn't really matter. So the optimizer will discretize the trajectory in the time domain, and at every point it will try to comply with all the constraints and iterate over possible variations that are allowed by the dynamics in order to maximize or minimize the objective function. In this case, the objective function has an end cost term, which is the time, so you want to minimize the time, and also has a path term, which means that all along the path you want to avoid spikes in the controls. We can talk about it tonight at the party if you want.
It's in continuation to what he asked. So I'm assuming that this kind of algorithm can be used on helicopters, and it can be plugged into this flight computer, and it can give a path that a helicopter could then track to land. And then the point comes, since I don't know completely what kind of optimization it's doing, and it's a trajectory, so I'm assuming it's position, velocity, attitude, and across all the different time steps that it will have. So there will be like, I don't know, maybe 1 million points, or maybe less, I don't know. I was wondering how much time this algorithm takes, and if there is a problem in real time, can it recompute on the flight?
Yeah. So a lot of questions, let's say, spread around your observations. I'll try to address them all one by one. First of all, you're correct, this is an offline optimization. So this is not carried out online because it takes too much time. And also it's not the purpose. So it's not a closed loop optimization where you want to find only the next step and continuously correct for it. What you want to have is a globally optimal reference that you can use as a reference signal to track. So this work has to happen beforehand. The points are not millions because it's very computationally expensive, and in fact that's the reason why the models have to be so simple and smooth. Already if you start adding many degrees of freedom for the rotor, motions, flapping, tilting, it's too much. And usually these type of optimizers find it very hard to deal with. So it requires careful modeling to have high level but globally optimal solutions that you would not have otherwise. For the information, in this case, the degrees of freedom of the helicopter are only translational. So you actually only end up with the trajectory and with the thrust direction that allows you to fly that trajectory. Now, from those, you can derive some other parameters like the rotor angles and maybe some altitudes, but mostly along the trajectory. So flight path angle, heading, and other stuff. But there are something you're forced to leave behind, like the body attitude rates, for example. You cannot get them. Yeah?
Great. Thank you very much, Professor Variale. If there aren't any other questions, the next speaker is Warrant Officer Michele Palumbo from the Italian Air Force. The stage is yours, please.
Hello, can you hear me? Can you hear me?
Yes.
Okay, good evening, everyone. It's a massive, massive honor for me to be here. I try to share my screen. Let's see whether it works. Okay. Just a second, please. Okay. I don't know whether you managed to see my screen. Would you give me any confirm about that?
Not yet.
Oh. Let's try this way. Let's see if this works. Okay, what about now? Nope.
Not
Hello
yet.
again? Oh. Hello. I'm afraid.
Not yet.
Okay, let me interrupt and retry. Eccomi qua. Dunque, sto riprovando a connettermi. Io riesco a vedermi, però non vediamo la presentazione. Io sto condividendo, mi dice che la condivisione è nello status, quindi io ora ci riprovo.
Pasquale, can you see the presentation of Palumbo?
I'm sorry, no. We are waiting.
Vogliamo provare a uscire e rientrare?
Ecco, sì, di solito funziona. Riproviamo. Ok, facciamo così. Io abbandono qui. Torna a partecipare. Una cosa incredibile. Incredibile, guarda.
Try to go off and then get in again from the beginning of the link.
Okay, so I'll try reboot of the system altogether. Okay. Let's see whether it works this way.
Not yet. Can we postpone the presentation, Pasquale, in another time, another day? What do you think, Pasquale?
Look, the program is very full. If the captain may speak about his presentation, summarizing the main point, probably is better. Because we have no other possibility, okay? I'm sorry for this.
Yeah, it could be an opportunity, and then you spread the presentation by me and then to Pasquale, Professor Da Ponte. Just to summarize, what's the goal of the presentation?
Hello. What about now?
Yeah, that's fine.
Okay.
I got it.
Sorry for this mishap. I also hear a bad echo. I try to proceed to go on, notwithstanding. I beg your pardon. Anyway, let's hope it keeps working this way. So, my name is Michele Palumbo. I'm a flight test engineer from the Aerospace Engineering Group, which is a branch of Aerospace Test Division. We were born in 2014. We aim to expand the Air Force capability in the new space domain through research, study, and experimentation activities. So within the scope of the presentation today, innovative strategies in space debris management. Our approach, the ISOC approach. So what is it all about? ISOC is an online tool made by the Italian Air Force with help from research groups and companies like Leonardo. It's used to gather and analyze data about objects in space, like satellites. It also has events related to space surveillance and tracking of space surveillance awareness. Much more about that later. So ISOC can estimate conditions, risks for satellites, predict when objects will react to the atmosphere, and study orbital fragmentation. We are particularly focused on fragmentation because we are responsible for providing fragmentation analysis in the European Union. But what about the fragmentation analysis? It's a service that aims to spot and describe when things split up in space and looks into all details about the objects involved. So let's move on. Let's take some steps back in order to frame the picture, that we have the big picture, so talk more about the problem. But at a given speed, everyone knows altitude increases and the atmosphere gets thinner and thinner, the effects of air resistance decrease until they become negligible in the Kármán line. But the Kármán line is not a line, it's an imaginary one, about 100 kilometers. When an object is still pulled toward Earth by gravity, but its forward speed delays its forward in an indefinite way. But gravity's effect is weaker in outer space, but it stays significant over time. So unlike an aircraft needing constantly thrust to balance aerodynamics forces, satellites, once at the right speed and altitude, only uses propulsion for maneuvers or to counteract gravity and stay in orbit. Once a satellite reaches its desired height in space, it's not to follow laws discovered by Kepler, Newton, along with Einstein, with universal gravitation. These principles help us study orbital parameters like size, shape, and orientation of the orbits. There are 5 key elements that uniquely describe an orbit: the semi-major axis, the inclination, the eccentricity, the right ascension, the ascending mode, the argument of gravity, and there's a 6th one, which is the two anomaly, that tells us the position of the satellite along its orbit at a specific time. It is just an angle between the perigee and the satellite's position at that time, so it's the only parameter that changes over time. Why this is so important? Because this means that we can predict an orbit very easily and adjust our sensors to follow an object as it passes overhead. It's called sensor planning. We determine the best position, angle, and time to observe specific areas of objects in space. Well, in a typical observation, a network of sensors, a single object like a payload, a debris, or rocket body, as it enters their field of view. Using the data, its observations, we perform an orbital determination, literally estimate, work out the object orbit in areas where it's not visible, so-called blind spots, and trace a likely path, excluding any inconsistent data. Well, in statistics, inconsistent data are called outliers. These are observations that are far from accurate in a data set. Outliers can distort analysis and lead to incorrect conclusions. They might occur because of measurement errors, experimental variability, or real rare events. Identifying and handling outliers properly is important for accurate and reliable results. So we can track in tracking mode. Well, following any given object, its orbit is known. Or can track in a survey mode. A survey mode, it means that we can scan a patch of sky searching for new objects. But we can choose different partner, linear, spiral. But anyway, what if we discovered multiple objects when we were only expecting one, or stumbled upon a cluster of unknown objects not listed? I'm afraid I'm lost. Hello, can you still hear me?
Yes, you can go ahead.
It's not my fault, I'm trying my best. Okay, so let's get started. So let's pick up the thread. So when we see more points, we're expecting just one, but probably a fragmentation is occurring. A fragmentation can be a problem because we are asked to track and separate a bunch of objects instead of just one. A network of sensors includes radars, telescopes, and lasers. Every one features unique outputs and unique biases. So we need to link and organize data so it shows exactly what is going on up there. So a fragmentation may be sparked by a satellite breakup, a disruptive explosion, a deliberate release of fragments, an anti-satellite missile action, a collision between orbiting objects. So the primary known cause that triggers satellite fragmentations are propulsion-related occurrences and deliberate actions. By and large, we can define a fragmentation as disruptive dissociation of an orbital payload, a rocket body, or structure, often with a wide range of separation speed. As a rule of thumb, low altitude debris are 10 centimeters across, while at high altitude, the object less than 1 meter across may be undetectable. But rare as it may seem, fragmentation events pose a serious risk to spacecraft and sometimes especially in low Earth orbit. By far the most important category of human-made on-orbit objects is debris from fragmentation, which accounts for almost 50% of the total satellite population. The graph on the right hand. So things have got worse in the aftermath of the anti-satellite test conducted by the Russian Federation on the 15th November 2021. The target of the test was Cosmos 1408, a non-operational Soviet satellite. The Cosmos 1408, as you can see from the slide, well, this test will impact all activities in low orbit, especially at operational altitude where ISS is operative, for the next 5 years at least, until it's estimated that 90% of its debris will re-enter the atmosphere. There is to say, the increasing number of launches does not necessarily reflect an increase in risk. The increasing number of debris does it. This is because more and more mitigation procedures are being put in place nowadays, such as those used by SpaceX for the Starlink constellation launches. But how do we keep track of what's happening in space after a fragmentation event? Well, at ISOC, we have developed two methods: international designator screening and puzzle screening. But the first one compares our data with the American database. Well, Americans have been collecting data since the Sputnik era in 1957, so they often happen to be pretty much better than us, do they? So they usually manage to classify new objects in orbit before us. So since all fragments of a parent object, a parent is the pristine object where all the fragments come from. So a parent object shares the same international designator except for the last letter. International designator screening involves comparing catalogs and updating them. It's very straightforward. It's kind of like cheating, but it's basic and effective. The second way we keep track of what's happening in space after a fragmentation event. Well, do you remember the parameter we talked about before? Well, we imagine a cloud of fragments, and instead of tracking them forward, as the orbital determination process usually works, we trace them backward until the fragments and the parent converge. If they don't, well, fragments will not be related to that event. The study is made possible by an algorithm developed in collaboration with the Polytechnic University of Milano, focusing on comparing the famous orbital parameters. So by using both ways to relate data to a fragmentation event, we usually start having a good big picture of the event and related fragments 3 weeks after the breakup. What the international community expects us to give out is the fragmentation analysis in several graphs and 3D pictures. Among them, the Gabbard diagram is probably the most valuable for our purposes. But these Cartesian graphs plot the altitude of the perigee and apogee of the parent object and its fragments on the y-axis, and the orbital period and the x-axis. It was invented by John Gabbard working at NASA during the early years of space race. So don't make the mistake, please, of thinking the diagram as a pictorial representation of an explosion event. It's a graph, so it's an analytical image, which can be counterintuitive, but once we understand how to read it, boom, the event becomes clear like a revelation. Depending on the amount and direction of the delta velocity received, each single fragment is subject to an increment or decrement of its orbital energy, leading to an apogee raise or energy drop. So from the Gabbard diagrams, we can gather the natural orbits, the location in space and time of the fragmentations, the speed and direction of the fragments, the statistical distribution of the fragment clouds. But this moving picture here shows how Gabbard diagram related to Cosmos 1408 debris changed over time, in a time of a year. The interjection point, the apogee and perigee, roughly marks the exact location where the fragmentation occurred. The data point defines two intersecting straight lines forming the shape of a very, very large inclined X. The points are scattered, but within a logic, in a logic structure, above and below the apogee and perigee lines. The angle between the lines are commonly devoid of points, especially on the right-hand side. In this case, the fragmentation occurred at very low orbit, so the reason why the left hand is not void of point is due to the atmospheric drag. The drag tends to synchronize the orbit to make it a regular circle, moving the points inside the forbidden zone on the left. It's easy to deduce then how debris tend to re-enter and decay to the Earth. So the higher you get, the smaller the decay rate becomes. So we're actually seeing a moving graph of debris re-entering the atmosphere. So why we do that? We aim to check the orbit for possible collisions with important national and private assets. We provide the so-called early risk impact analysis, a well-known method for the analysis of collision activities following a fragmentation. The cube algorithm is an algorithm that considers the fragmentation clouds along with the background population of objects that we want to include in the collision risk analysis. We consider a total inclination times, and we divide the inertial space in many cubes. We check if two objects are within the same cube, and in this case, we compute the collision rates by using different methods and approaches. So it is clear that could not be a more favorable context than this conference to invite new collaboration projects. There's still a lot to work to do. Still a lot of road ahead. There is much to be done. And we can do it together with students, prepare the PhD with us, together with universities and research institutes, through cooperation agreements, together with companies, corporations, startups, thanks to the PNRM funds. The fragmentation problem can be handled from a statistical point of view, from the aerospace perspective, from a genuine math approach, and cooperation with programmers are more than welcome. But if this brief presentation, though a lot of problems come across, and I'm sorry that it's not my fault, well, this brief presentation sparked the imagination, but you know that our doors are for you all. Sorry again, and attentions.
At the end of your presentation, Michele?
Sorry again?
Are you at the end of the presentation?
Yes.
Because we had a stop on your presentation on the slide 10. That's why we couldn't see slide 11, 12, and 13. Thank you for your presentation. Are there any questions from the platea, Pasquale?
Any questions? No. From the room, no.
So, okay, I conclude the International Military Panel organized by AFCEA Chapter Naples. I want to thank you very much, Michele Palumbo, for attending as a speaker today. I want to thank Professor Variale and Engineer Alfonso Centuoi with SDM Polska company is our sponsor for the MetroAeroSpace 2024. That the presentation gave them a lot of information related to the highlights of the MetroAeroSpace. Thank you very much, and hope to see you again next year at MetroAeroSpace 2025 in Naples. Isn't it, Pasquale?
Yes, it's a surprise, but now we may say it will be Naples.
Ah. Sorry. Thank you very much, Pasquale.
Ciao, see you.
Have a nice evening at the ice breaking of MetroAeroSpace. Thank you. Thank you. Bye.
So now, according to the program, there is something that we devote to the women in engineering. Is as you know, IEEE try to open as much as possible this field to the presence and activity support of the women in engineering. And the IEEE has a specific affinity group for this. So Gianluca, all is ready? Okay. Thank you.
Hello. Good evening, everybody. Thank you for coming to this IEEE Women in Engineering Affinity Group panel. My name is Michele Fiorini. I have the honor and privilege to chair this panel tonight here in Lublin, Poland. We have about half an hour slot, and the intention is to split this time in three main parts. First part will be an introduction of the panel run remotely by Claudia Conte, which follow us online. I will introduce you, Claudia, in a moment. After the panel presentation, we move on to an invited speaker, Ms. Ansela Adunia Mekonen. I hope the name is at least acceptable. Which she will present his experience and achievement so far. And then I will open to Q&A session and discussion about the important role of engineering and the presence of women in engineering and the topic presented today. Without any further ado, I would like to introduce Dr. Claudia Conte. She is an untenured assistant professor at University of Study of Naples, Federico II, within the National Center for Sustainable Mobility, and she is teaching the course Aircraft Onboard Systems for Aerospace Engineering Master Degrees. Her research activities are focused on standardization of core enabling guidance, navigation, and control technologies for autonomous transport systems, and solutions for unmanned traffic management, exploiting artificial intelligence-based techniques. Now, Claudia will introduce the topic of IEEE Women in Engineering Affinity Group panel. Please, Claudia.
Thank you so much, Michele. Thank you so much to chair this session, and thank you to all of you for joining us today. First of all, I would like to present you Professor Patrizia Lamberti. She is the chair of the IEEE Women in Engineering Affinity Group Italy section. So I would like to introduce her So please, Patrizia.
Good evening to everyone. Sorry if we are not in presence with you, but sure we are with you also if we are far. IEEE Women in Engineering try to share competence, experience, but also open the route for the younger research. So today I want to give my welcome from the IEEE Women in Engineering section, but I prefer that Claudia was the real young researcher that can really introduce the activity that we are performing since 4 years jointly. A special MetroAeroSpace was our first experience. Me and Claudia were in the same panel several times, and this year we decided to give the space to Claudia directly. So welcome to everyone, and please, the floor is for Claudia Conte.
Thank you so much, Patrizia. It was a pleasure for me attending this panel during the last years, and thank you for joining us today. So I have just a couple of slides that I would like to share with you, just to present you which is the mission and vision of IEEE Women in Engineering Affinity Group Italy section. I'm an IEEE Women in Engineering volunteer, and I would like just to summarize with you the main steps that allowed to develop the affinity group in Italy section as it is. So the affinity group of the IEEE Italy section was born in December 2016. So now it was born more or less 8 years ago. And the main idea that drove the development of this affinity group was the idea to support the presence of women engineers from academies, industries, and institutions in general. So the main aim is to promote and sustain the role of women engineers in several fields. But starting from this idea, of course, the concept has been extended to STEM disciplines in general, so considering topics in science, technology, engineering, and mathematics. Considering that usually the role of women and also the number of women in some cases represents a minority. So the main aim of this group is to support the role of women, underline the contribution that women can apport to STEM disciplines. In this slide, you can see also the website of our affinity group, where there are all the news and events that we collaborate to design and also to develop. So we are used to schedule events such as the today's event to try to share ideas with young researchers, but also with experienced male and female that work in topics related to STEM disciplines, in order to share ideas and especially experiences, to try also to inspire young professionals and young researchers to STEM disciplines. The focus of our activity is, let me say, summarized in the commitment chart that is named Steering Girls to STEM. What is this chart? Well, this is an open document because starting from the first version, we achieved the third version because it is an annually updated document because each year we try to also analyze the achievements and the results that have been obtained by the affinity group in order to identify some improvements topics of action. So some goals that can be analyzed in order to support the role of women in STEM disciplines. So this document describes the shared objectives and the targeted actions that the organizing committee and the supporting committee undertake to carry out, also with a focus for young professionals and young researchers. The development and the update of this document is carried out by a coordinator that is the chair of our IEEE Women in Engineering Affinity Group, but we have also a promoting committee that includes all the associations that you can see in this slide, because it's important also to collect the contributions of all associations, members that are strongly involved in the development of actions, supporting actions to for the female role in STEM disciplines. And then we have also the supporting committee that supports the development of this chart. So, considering the main objectives that are included in the commitment chart, I would like just to focus on these 12 items that are listed in the commitment chart. I would like just to remember that this is an open document, and of course it is available also online at our website. And of course we are always happy to receive suggestions, contributions, and also some focuses that can be very useful to improve next year also the commitment chart. As you can see, just reading these 12 items, an important topic that I would like to underline is that our contribution is not only related to high levels of academies or industries, but starting from schools, because it's important to share the ideas underlining the role of women in STEM disciplines and underlining the importance of gender equality in STEM disciplines, starting from young children. So our effort is also to try to share this goal with teachers at starting from elementary schools to allow to create a sharing environment. So starting from the schools, our effort is to develop topics for supporting the role of women in STEM disciplines. But of course, another important goal is to inspire and inspiring and mentoring, because it's important to create events such as today's event to present important contributions of experienced or young researchers or professionals in STEM disciplines, in order to share these contributions and to present role models that can be female role models also for young researchers. The role of family is another important goal of our commitment chart, together with sharing of skills, promotion of best practices, so to try to identify some best practices that can always be applied to support our goals. And of course, these aims are also related to underline the advantages that can be obtained from the presence of female and male roles in the same environment, in order to create a collaborative environment. So effective communication is needed to properly share the goals. but also the possibility to share own initiatives, involvement of institutions, support to school offices to apply for fundings, because of course sometimes also school offices need some help to apply for fundings in this sector, and search for financial support for the initiatives. At the end, the last objective that probably summarizes our effort is also to map not only our actions, so all actions that we implemented during the last year, but also to map the actions that have been implemented by other subjects in order to analyze these actions and try to improve our actions for the next year. So I don't want to be longer. So thank you so much for attending this very short introduction, this short overview. And now I would like to leave the floor for the next speaker, that is our invited speaker, and I'm sure that she can represent a very interested contribution to share her experience in STEM disciplines. So thank you so much.
Thank you very much, Claudia. Let me just say a few words to introduce the next speaker. And thank you also for the timing respect. So, Ms. Andesa Adunya McGrawn graduated from Addis Ababa University with a bachelor degree in geology and a master's degree in remote sensing and geoinformatics. Her thesis work was GIS-based landslide susceptibility zonation and risk assessment in complex landscapes, a case of Beshilo watershed in northern Ethiopia. She worked as a graduate assistant before earning her master and then moving into lectureship before starting her PhD program. She is pursuing her PhD after receiving a prestigious prize from the Italian organization ENI. She is currently a PhD student at University of Naples, Federico II in Italy, and her research interests are spatial analysis, image processing, photogrammetry, in general application of GIS and remote sensing to geosciences, environmental sciences, vegetation and climate. Please, the stage is yours.
Thank you very much. I am Anitra. I'll be thankful from the slide. So who is Anitra? Is my title. Okay, I'm going to present myself. It's not a scientific research, just to share experience. It's a pleasure to share my experience, even if I am too young researcher. But I can be a model because I am a mother, I am a teacher, and I am a young researcher, let's say, because I am doing a research in my PhD. So I'm going to present myself. If it will be an inspiring things, I can start just who is Andra. I want to focus on academic qualification, as Michele Piori explained about myself and work experience, precise and recognition received in my home country, and research interest. So I'm going to say something about these four things. So who is Andra? My academic qualification is, by background, I am a geologist. I received my geologist degree, my first degree, in Addis Ababa University, Ethiopia. If you don't know Ethiopia, it's Africa. So my second degree is in Masters of Remote Sensing and Geoinformatics in the same university, Addis Ababa University, Ethiopia, Africa. And my thesis work is GIS-based geoinformatics-based landslide susceptibility, mapping our complex landscape over northern Ethiopia, because it's based on observational-based research idea. And this is already published in Environmental Challenge and journals. To share my experience, even if it's too little, I was working for 2 years as a graduate assistant before attending my master's degree. And during that time, I was working as a geologist. I was a lecturer for bachelor degree students who was taking their degree in geology. And this photo is just taken from the field. I bring this one to say that women can work everywhere. And when I was a university lecturer in my home country, I completed my project, which was funded by the university and organization which was empowering female in the university. And this was just about land susceptibility assessment for agricultural crops by using GIS-based multi-criteria approaches. It's also in northern Ethiopia. Okay, in this case, I was a principal investigator for the work, and the result is just explained like this. I don't like to go in detail about the work. The next two things that I like to present is just a prize that I received from Italian president, which is rewarded by President Signore Mattarella, if I am correct to pronounce Italian words. The ceremony was in Roma, as you see from the picture. I was here. And I also received so many recognition certificates from my home country, just because of a leadership in women empowering at university especially. I'm very passionate to promote young females. This is just my life passionating. I don't know why. I'm very interested. Maybe I come from, maybe it's very, very difficult to break the culture in my country. So I'm very passionate to promote these things. And I was working for mentorship for female students in university. Currently, I am a PhD student in Federico II, Naples, University of Naples in Italy, after pursuing this prize by ENI. And my research interest is about sustainable agroforestry. Now I am applying to use drone image, since I am here in MetroSpace conference to present my activity. I will present tomorrow. It's about agroforestry. When we talk about agroforestry, I'm trying to understand the use of unmanned aircraft system, which is just the application of unmanned aircraft system to understand the biomass or the carbon sequestration capacity of vegetation by estimating above ground biomass. After estimating this biomass to understand the climate change variability. So this is just about my current work, because we are just focusing in agroforestry. I just proposed this research because I saw some research gap in my country. After I proposing this research, I am trying to do an experimental work in Italy, just to use drones, and I will try to use, based on this result, to use freely available satellite imagery to understand the climate change variability in Central Africa, because there is, since Central Africa, Northern Africa, because Ethiopia is part of Sub-Saharan Africa, nowadays climate change is becoming worse in that case, and I am trying to understand agroforestry practice is more important for climate change mitigation. So I don't like to go to details about the advantage of unmanned aircraft system because I will present tomorrow before lunch. So I'd like to say thank you for this, and women can work everywhere. Just say, I can do, never stop exploring. Thank you very much.
Thank you very much for this interesting and inspiring presentation. So now it's time for question and answer, either from the room or remotely. So maybe I will give advantage to people online at the moment, if I don't see any hands here.
Yeah, I would like to ask Ansera, which are the main drivers that allowed you to start to study STEM disciplines?
Okay, thank you for the question, Claudia. The driving factor for me is maybe challenge, because when there is challenge, just don't let them to ignore. Just to try to break this challenge and become a model, because this is work for me. I came from just a rural part of Ethiopia. You can't imagine how much it's difficult, but nothing is impossible. So challenge make me to be strong. Why I am here in front of you, it's because of hard working. I can say that. Because I can say that I am an orphan. I just help myself. So hard working is the key point. I don't know if you can understand how much it's difficult in Africa. I think you can understand how much it's difficult, but nothing is impossible. If it is the answer, it's like this. My driving factor is this.
Thank you so much. It was a really, really nice presentation. Thank you. Thank you so much for joining us today.
Okay. Thank you, Claudia. Thank you, Patricia. Thank you for inviting to be as a speaker.
It was very welcome. Well done.
More questions, comments? I saw a number of women in this room for the level of participation. And okay, so thank you again, and we can close here the session.
Thank you, Michele.
Thank you very much. We'll take care of this for us.
Okay, thank you again from all of us. We can close the section here for today.
Goodbye.
Good night, everyone.